Okay guys, welcome to Bird Math in my inaugural video. And today what I wanted to talk about is the following formula. So the indefinite integral of u dv is equal to uv minus the integral of v du. Now I'm going to derive this formula, and I'm going to show you where it starts from. Typically, an integral that you'd want to use this on is something like this. Say I asked you to find the indefinite integral of e to the x sine x dx. Simple u substitution will fail there. And because of the way that u substitution is pretty much derived from the chain rule, it follows from the chain rule for derivatives, integration by parts for integrals follows from the product rule for derivatives. So if you haven't heard of the product rule, it's the following. If I say, give me the derivative of a product, f of x times g of x, well, it's equal to the derivative of f times g of x untouched plus f of x untouched times the derivative of g of x. And if you've heard of the product rule, you might also know the following. That this is an operator. It says take the derivative of whatever inside these brackets. Well, in calculus, one of the things you learn when you're taking calculus is that differentiation, which is a mathematical operation, like all mathematical operations, has an inverse. And that inverse is integration. So integration is the inverse of differentiation. Just like division is the inverse of multiplication. And just like division will undo multiplication, so for instance, if I start with 5, multiply it by 3, I get 15. But then if I do the inverse of what I did, so I multiply by 3 here, if I divide by 3, I'm right back to where I started with 5. So multiplication and division undo each other or cancel each other out. And it's the same thing with differentiation and integration. And so, because of that, I can rewrite this entire line like so. So I can basically take the integral of this derivative and get back right where I started. And that's what this line shows. Okay, now I'm just going to do a little bit of algebraic manipulation. This should be easy to follow. We're just going to subtract Okay, now what we're going to do is just use a property of integrals. And a property of integrals, you may remember, is that you can take the integral sign over addition or subtraction. So like so. these lines are equivalent from here to here. All I did was take the integration sign over this sum here. Now, I'm going to do some algebraic manipulation. Should be easy to follow. I'm just going to subtract this integral from both sides. That's not a negative sign, sorry. Okay. These should cancel, and we're left with the following. Okay, and we are done. This is the formula for integration by parts. However, it's usually presented to students in a way that uses u and v, and that's how we had it originally up here. So to do that, I'm going to pick a u, I'm just going to change the variables. I'm going to write this in terms of u and v. So if u is f of x, then du is f prime of x dx. And I'm also going to pick a dv, which should be g prime of x dx. And therefore v, which is the integral of dv, is just g prime of x. And now let's rewrite this formula using u and v and du and dv. So the original on the left says f of x times g prime of x dx. Well, f of x is u, and g prime of x dx is dv. So u dv is equal to f of x g of x, so that's simply uv, u times v, minus the integral f prime of x, which is du. So f prime of x dx is du. And then g of x is v. So this is going to be the integral of v du. And that, ladies and gentlemen, is the formula for integration by parts. And that is the derivation of the formula from the product rule. Thanks for watching. I really appreciate it. If you guys like this and want me to continue, I'm going to do an example to show you how to use the integration by parts formula. Stick around, follow me, and I'll be posting that soon. Thanks a lot.